Let us now see how to make series parallel circuits onto the breadboard. The first circuit which I have taken here is a simple series circuit which has three resistances connected in series. So let us assume this as resistance R1. This resistance R1 can be placed anywhere randomly. Okay. The application of the rules starts with the second resistance. So here I can clearly see that resistance R2 is connected to the second terminal of R1. So let me do the same for my breadboard. So as I have told you earlier, these 5 holes in this column are connected internally. So I can say that second terminal of resistance R1 and first terminal of resistance R2 are being connected together here. Now as I can see in the diagram that the third resistance is connected to the second terminal of resistance R2. So what I can simply do is connect the first terminal of resistance R3 with second terminal of R2. Now let us assume that this is your positive supply. So your positive supply is connected to the first terminal of R1, which can be connected here, and negative supply is connected to the second terminal of resistance R3, which is here. So in this manner your basic series circuit is completed. So let us verify it one more time. Let us assume that this is the first terminal, this is the second terminal, first terminal, second terminal, first and second terminal. So let us verify one by one. First terminal of R1 is connected to the positive supply. Let us check here. Yes, I can clearly see that first terminal is connected to the positive supply. The second terminal of resistance R1 is connected to R2. Let me check it here. The second terminal of resistance R1 is connected to R2, and similarly R2 and R3 are connected. Let us now take our second example, which is a simple parallel circuit wherein three resistances R1, R2 and R3 are connected in parallel. Now let us try to make this onto the breadboard. Let us take first resistance R1. I am going to put it anywhere onto the component rail. Now as I can clearly see here that resistance R2 is connected to the first terminal of R1 and the other terminal of R2 is connected to the second terminal of R1. So if I take this as 1, this as 2, and this again as 1 and this as 2, so I can see that 1 and 1 are connected together. So let us assume that this is the first terminal of resistance R1. So I have only 4 options left to connect the second terminal, or you can say the second resistance R2, which could be among these 4 holes. So now let me put R2 here, and similarly the second terminal I have put here. Now let me first put resistance R3, then I am going to explain to you as to why I have done this. So basically what this diagram is, this is somewhat like this is R1, this is R2, and this is R3. So you can see here that all the first terminals of resistance R1, R2, R3 are connected to a single load, and all the second terminals of resistance R1, R2, R3 are connected to a single node, which has been done here. If you look closely, you can see that all the first terminals are connected in a column, which means that they are connected together. Similarly, all the second terminals are connected here, which means that these are connected in parallel. So let me assume that this is the positive terminal, so the positive terminal also goes to node number 1. So I have only two options left, which is these two holes. So I'll put it somewhere here, and let us say that this is your negative terminal. So negative terminal is going on to the second node, which is somewhere here. So in this manner your parallel network has been made onto the. So as far as the third example is considered, I have taken a combination of series and parallel circuit where R1, R2 and R3 are connected in this manner. So let us now try to make this circuit onto the breadboard. Let's take the first resistance R1 and I put it here randomly. Now as far as resistance R2 is considered, it is meeting resistance R1 at this junction. So let us take R2 and connect its one terminal to the second terminal of R2. Okay. Now as far as R3 is considered, first terminal of resistance R3 is connected to the same junction, meaning that each second leg, or you can say one leg of each resistance, are connected together. So let me take resistance R3, and if I am supposed to connect it on the same junction, I have only three options left in this column, 1, 2, 3. So I am going to put it somewhere here. And now as far as the second terminal of resistance R3 is connected, let us see where it is connected. So it is connected towards resistance R2. So on the breadboard I can see that second terminal of resistance R2 is here. So if I am supposed to connect one terminal of R3 with this, so I have only 1, 2, 3, 4 options left. So let me connect it somewhere here. See, now let us verify. First terminal of R1, this is the first terminal of R1. Second terminal of R1 is connected at this junction. So I have connected it in one of the holes of this column. Okay. First terminal of resistance R1 connected with the second leg of R1, which is again in the same column. Now considering the first leg of resistance R3, it is again at the same junction. So I have again connected it onto the same column, one of the holes of same column, and these two legs are connected together, as can be clearly seen in the diagram. So as far as power supply is considered, let us assume that this is the positive terminal. So positive terminal is going to R1. Let us connect it somewhere here. And as far as second, or you can say negative supply is considered, negative supply is going to a junction where R2 and R3 are joined. So it could be here. In this way your connection could be made. Another alternative method for making this connection is let's assume that you have connected R1 randomly here, and as far as R2 is considered, I have joined this with R1 here, but the other leg I have connected somewhere here. Alright, so again, what would happen when I am supposed to connect R3 to the same junction? So I'll connect it somewhere here, meaning that all the three legs of the three separate resistances are connected onto this column, meaning they are connected together. And the second terminal of resistance R3 goes with R2, so I'll connect it somewhere here, because I have only 4 options left. If it is to be connected with R2, I have to connect it to the same column where the other terminal of R2 was connected, so I have connected it here. And let us now connect the supplies, which are positive terminal goes to first leg of R1, connected here, and negative supply will go to R2 and R3, which is here. So in this manner this circuit is complete. So for example number 4, what I have done here is I have increased its complexity. I have included one more resistance, which is resistance number R4. So now I have R1, R2, R3 and R4. The first thing I am going to do here is let me number its terminals. Let me write 1, 2, 3, 4, 5, 6 and 7 and 8 for terminals of resistance R4. So step by steps now, let me take resistance number R1. So as I've shown you in previous example also, that as the size of your network increases, what you can do is you can use more number of segments. In last example also I have used this and this segment. If the size of your network is small, you can go with a single segment also. So let me take a resistance number R2. Here I can clearly see this is terminal 1, this is terminal number 2. Now I have to take resistance number R2, which has terminals 3 and 4. So 3 here is connected to 2. So let me connect 3 with 2, and I am going to place number 4 here. Now let me take resistance R3. So for R3 I have to take terminals 5 with terminal number 2. So this is my terminal number 5 and this is the terminal number 2. So I'll have to connect it in the same corner like this. Let me connect terminal number 6 anywhere. So as far as resistance number R4 is considered, I'll now have to deal with terminal number 7 and 8. So let me connect terminal number 7 with terminal number 6, which is somewhere here in this column. Okay, and now terminal number 8 is going to be joined with terminal number 4, which is somewhere here. So wherever the number 4 terminal is connected, I have to check the same column, and in that same column I can connect it to any hole. So in this manner this diagram has been completed. Now let us put voltage supplies. Positive is going to terminal number 1, so I'll connect it somewhere in this column. So I have the option of 4 holes, so I can put it in any one of the 4 holes. And as far as negative supply is considered, it is going to terminal number 4, which is somewhere here. So I'll connect the negative supply here. Fine. So let us see how this circuit can be made alternatively using the lower segment also. Let me take resistance R1 and connect it anywhere. Now if I am taking resistance number R2, which means terminal 3 and 4, I have to connect 3 with number 2. So I have connected 3 with 2 here, but 4 has been connected to the power rail. I have told you earlier also, this is known as your power rail. So I have connected it in the power rail, and to remind you that the holes of the power rail are connected horizontally, meaning all these are onto the same potential. If we see the upper segment, it is connected vertically. So now let me take resistance R3, which has terminals 5 and 6, and 5 is supposed to be connected with along with 2 and 3, which is right onto this column. I can connect it anywhere in this column. I had only 3 options, so I connected it here, and terminal number 6 can go anywhere for now. Let me take resistance R4, which has terminals 7 and 8. 7 is connected with 6. This is terminal 6. Now I have to connect 7 with it. So I have only 4 options which are onto the same column. But now let us consider terminal number 8, which has to be connected with 4. Now 4 and 8 will be connected in this fashion. Why? Because I have told you earlier also that this segment is connected horizontally. So instead of putting this terminal vertically downwards onto that column, what I have done here is I have connected it in a horizontal fashion. Now let us take the supplies. Positive supply is going to terminal number 1, so I'll have it somewhere here, and negative supply is going on to a junction where terminal 4 and 8 are connected. So terminal 4 and 8 are connected here. So I have the freedom of connecting negative terminal anywhere in this upper horizontal line. So in this manner your circuit is complete.